Hi, welcome back. In this video, we're going to talk about how to implement the programs. We have learned how to design the algorithm and how to divide the problem into small modules, and now is the time for us to implement the program. A computer program is a series of instructions that directs a computer to perform tasks, so we need to use the programming language to make the program. So the instructions inside of the program is written in a programming language, can be translated into the instructions that the computer can understand and execute directly. So translate is an important step. The programming language cannot be directly executed by the computer. It needs to be translated into the machine code, which is binary. A program is a meaningful sequence of instructions for a computer. So what you need to do is to write a program. You need a lot of instructions to implement the program, and of course, the instructions need to follow some syntax and also has the correct semantics. Here shows you some classical programming languages like C language, Basic language, Pascal language. Some of them are pretty old language, but it's still very useful recently. So as you can see from the figures, each of the computer language may have different syntax. You can see that the C language is similar as the Pascal, but is quite different from the BASIC. So different programming languages have different expressions and statements, but they still share a lot of common things, like the control structure we have introduced in the previous video. Any language can only have three basic control structure: the sequential control structure, the selection control structure, and the repetition control structure. They may use the different keywords, but the logic are same. There are plenty programming languages since the first generation of the computer. Some of the languages are not widely used recently, but some of them are still very popular, like the C language, Java, Python, and new programming languages are also coming out, like the Go language and the Rust language. So if you want to make a program, you need to have some software tools. Usually you need these four types of softwares, like the editor, which is the text editor, just like a notepad. We do have some particular editors for the programming languages because it's going to make the programmers easier to make their program. When the programmer finishes their editing, they can save their program as a file, and we call this source code. The source code cannot be run directly on the computer because it's not binary. So we need some tools to convert from the source code into the code that the machine can understand. And we are going to use the compiler and linker. So the compiler will translate the source code into the object code, which is binary. And the linker may be converted from one or several object files into one executable program. So in some of the programming language, you need a linker, but some of the programming language, you probably don't need the linker. Another software is called debugger. So debugger is a software that you can use to fix the problems in your program, because no one can make an error-free program. So you probably need to analyze your program. You need this tool to run your program in a slow motion, and also you can investigate the values in your program to see whether those values or logic are correct. So the mistakes or errors in your program, we call it bugs. There's an interesting legend for the bugs. The term bug is firstly appeared in 1945, and it's written in a notebook by the first generation of the programmer, whose name is Grace Hopper. She was trying to fix her program, and eventually she found out that the problem was that there's a small mouse in the relay. So she noted this situation. From then on, the mistakes or problems in the program are called bugs. Try to fix a bug, we call it debug. Now let's look at the different categories of the programming language. We basically have four generations of the programming language. The first generation of the programming language is the machine language, which is the binary code. Just like how we programmed in the first generation of the computer, we need to use the binary, and we even need to connect the cables. The second generation of the program is called assembly language. This type of programming language is easier to understand because we use some English terms to represent some specific instructions like addition, subtraction, or copy. The third generation of the programming language is the procedural language. And for this generation of the programming language, it's more easy to understand because we use more natural language in the program. The fourth generation is non-procedural programming language, and we use this type of language in some of the different environments like the database. So what will be the fifth generation of the programming language? We still don't know, but maybe the pure natural language programming. The machine language is the first generation of the programming language, just like we showed on the right. So all of this are machine language. This is the only language that computers can directly understand and execute. So it's a series of machine-dependent binary digits, which is hard to write and understand. So you can imagine writing this type of program is definitely not easy, and it's also time-consuming. So making a program on the first generation of the computer is definitely a difficult thing. Assembly language is the second generation of the programming language. You can see from this piece of program, we use some English terms like EQU probably means the equal, or the name is easier to understand. So programmers write instructions using symbolic instruction codes such as add. So you don't need to write some binary codes like 0, 4, F, B, H to represent this addition. You can just write add to represent the addition operation. And this type of programming language cannot be directly executed on the computer. It has to be converted into the machine language. So the translator, we call it assembler. The input of the assembler is the program in assembly language, and the output of the assembler is the machine code. So you have to use the assembler to translate your assembly language into the machine code so that the computer can run your program. Suppose your assembler reads this instruction, it will be translated into this one. The third generation programming language is easier to understand because we use more English keywords. And you also need a software to translate your program into the machine code. For this generation of the programming language, we basically have two types of softwares. The first is called compiler. The second is called interpreter. The compiler will translate an entire program before execution, but the interpreter will convert every instruction during the execution of the program. The C language is a classical procedural language, and it is the origin of many modern programming languages, such as Java, C++, and it is still widely used, especially in some embedded environments or the lower level system softwares. This figure shows you some C programming statements. This part of the statement is called the comment, and it begins the slash and the asterisk. The comments will not be translated into the machine code. It actually will be deleted during the compile of the program. What actually will be executed is actually from here. So the if and else actually corresponding to the conditional structure. So if this condition is true, it will execute this part, else it will execute this part. And the printf is just an output statement. It will print out a string on the screen. So it's quite obvious that this type of programming language is more easier to understand and easier to make. Another type of programming language in the third generation programming language is the object-oriented programming language, such as Java, C++, C#, are all OOP languages. It's a little bit different from the procedural language, because in the procedural language, what you need to do is to design some procedure or functions. But in the OOP language, what you need to design is some object or classes. As we mentioned before, there are two ways to translate the program into the machine code. First is the compile, and then is the interpreter. For the languages that need compile, it's called compiled language. You basically need to follow this edit, compile, link, run, and edit loop. You use an editor to edit your source code, and then you try to compile your source code. If the syntax of your source code is all correct, your compiler will generate the object code. And then you can use linker to link several object codes into one executable program. And then you can check the logic of your executable program. If the result is not as what you expected, you can go back to the source code and modify your source code and then compile a link again. The process for this type of language is kind of complicated and long, because every time you want to modify your program, you have to edit your source code, and then you have to compile and link your program again. So we have another type of programming language, interpreted language. So for the interpreted language, you don't need the compile and link stage, you just need the interpreter. So what you need to do is to just edit your source code and then ask the interpreter to run your program. If your program is not correct, you just edit your source code and then ask the interpreter to run again. So you don't need to compile and link your program. These are the comparison between the compiler and the interpreter. So the compiler and the interpreter will both check your syntax, but the difference is that the compiler will generate the machine code instructions, but the interpreter will not generate the machine code, it will execute the program directly. But the good thing for the compiled program is that after you compile and linked your program, you don't need the compiler. You can run the program without the compiler. But for the interpreted programming language, you have to keep your interpreter, because every time you want to run your program, you need the interpreter to translate your program. So the executable runs faster and the interpreted program is slower. Let's watch a video to see what's the difference between the compiler and the interpreter.
When you land in the world of computers with their strange, convoluted machine language, it's a bit like landing on another planet whose inhabitants speak an equally strange, convoluted alien language. Getting a mechanic on planet Gobbledygook to repair your spaceship would present the same sort of problem that you have when you want to get a computer to do something. Everything you say has to be translated. And you have a choice between two different sorts of translator. One of them is called an interpreter, and the other is called a compiler. Let's suppose that you've previously written out your list of instructions for the repair of your spaceship. And suppose that you choose the interpreter to do the translating. He reads your first instruction, open lid of rocket engine, translates this into gobbledygook, and immediately passes it on to the mechanic, who executes the instruction. Then the interpreter reads your second instruction, remove spark plug, translates this into gobbledygook, and passes it on to the mechanic, who executes it. And so on and so forth. Now, notice how the interpreter works. He stays with you all the time, and he translates each of your instructions immediately, one by one. This is a rather slow process, because the mechanic has to wait while each instruction is being translated. But, on the other hand, it does give you a chance to correct your mistakes as you go along. If the mechanic removes the wrong spark plug, for instance, you'll see this happen right away, and you'll be able to change your instruction accordingly. Compare this with the way the second sort of translator, the compiler, goes about his work. He takes your complete list of instructions and without further ado translates the whole lot straight into gobbledygook. He then hands them back to you and goes away, leaving you all on your own. All this has taken some time, but from now on things will go very fast. You hand the complete list of gobbledygook to the mechanic and he executes them all in one go, bang, bang, bang. There's no waiting about this time. But there's one disadvantage to this, of course. If there was a mistake in your instructions, it's too late now. This analogy comes very close to the way the interpreter and compiler translator programs actually work with computers. An interpreter runs slowly, starts right away, and lets you see how things are going. Whereas a compiler takes extra preparation time before your program can run, but then lets it run very quickly and efficiently. To help you remember the difference between an interpreter and a compiler, look at the words themselves. Inter means between. The interpreter is always between your program and the computer, and it translates line by line. To compile, on the other hand, means to pile together. A compiler piles together your entire program and translates the whole thing all at once. Which one you use on Planet Gobbledygook is entirely up to you.
The fourth generation language is the non-procedural language. The SQL is one example of the fourth generation programming language. SQL is a language that's used in the database. We can use this type of language to search or query the data stored in the database. In recent years, there's another type of programming style. We call it Web 2.0 programming. The Web 2.0 allows websites to provide some essential functions for the programmers. So the programmers don't need to build their application from scratch. They can probably build up their application based on some existing functions. For example, you can make an application with a map, but you don't have to build a map from scratch. You can just use the API provided by the, let's say, Google Map. So if you use a Google Map API, you're going to have a map immediately, so which is very convenient. Here I show you some Web 2.0 APIs provided by the WeChat API. So nowadays, if you want to make a small application, like in China, you probably don't need to build an independent app. You can just make a mini program running inside WeChat. So it's easy for the programmers to share the program because there are billions of users already using the WeChat. They don't need to install the app again. They can just search your application inside WeChat and they can use your program. So let's see what's on this website. So here list you all the functions of the WeChat API. You can install the JavaScript SDK, and then you're going to have the functions like log into your application, managing the users, scan a barcode, and retrieve the result from the scan. You can also record a video. Your mini program can even have some complicated functions like the payment, the location service, or the fingerprint authentication. All of this shows you a different way to make a program. You can call this Web 2.0 APIs to make your program. Because of the time limit, we cannot teach you any actual programming languages in this course. But since you have learned how to design an algorithm by using the flowchart, it's going to be easy for you to learn any programming language. I think Python is a great entry point for whom doesn't have any programming experience before. You may think, I never used Python before, it's going to be hard for me to make the program, but that's not true. I'm going to show you how to learn Python in 1 hour. So this shows you how to learn Python fundamentals in 1 hour. If you say, okay, I don't have 1 hour, so how about this? Learn Python in 10 minutes. This is quite interesting. Let's just spend more time on Python. So Python is a programming language. It's an interpreted programming language, and it's a high-level programming language. It supports OOP, Object-Oriented Programming. Let's go directly into the program part. So the first thing you want to learn is to print out something. So this is the simplest thing. You want the computer to print out a string for you. Mostly programmers prefer to use a hello world. This is how you're going to use Python, as what we have learned before. Because Python is an interpretive language, we need an interpreter. You can definitely install the Python environment on your laptop, but the more convenient way is to just use some online environment. So this will be your first Python program, Hello World. You make a program and you name it py, which means Python. Py is the extension name of your Python file. In the first line, you design a variable which is a string, and the content of the string is hello world. And the second line is to just print out the content of the string. And then you can run your program. So this is the result. So you asked the computer to print out something for you. So this is your first Python program. If you want to learn some more complicated program, you can study from this website. It's going to teach you what are the data types and how to use different data types. You have int, which is integer, floating point number, long integer, complex data type, string, logical value. Let's just go to the control structure part. As we studied from the flowchart part, we have two types of control structures for the selection control structure. The first is the condition control structure. The second type is the case control structure. We use if and else, which are two keywords, to represent the conditional control structure. The expression after if is a conditional statement. If the conditional statement is true, it will execute this branch. Otherwise, it will execute this branch. You can definitely put more statements in the branch. Like here, we only have one print. You can put more instructions in this branch. The next control structure is the loop. So this is a loop. We use the keyword for or while to represent a loop. So this means that you have a list. And inside of the list, there are some numbers. For here means that for each of the element mark in the list, you're going to print out the mark. While is another keyword. For here, the statement after the while is a conditional statement. So it means that if the count is less than 10, you're going to continuously doing these operations. You're going to increase count by 1 and then print out the value of the count, and then you're going to compare the value of count with 10. If count is still less than 10, you're going to execute this part again. You see, it's easy to understand, and same as what we have learned in the flowchart part. There are also some other control statements and functions that you can learn. Here shows you how to define a function and how to use the function. And here shows you how to get the input from the user. So we don't even need 1 hour to study the Python program. So writing a Python program is pretty easy, and Python is widely used in the recent years, especially in the artificial intelligence area. Most of the programs are written in Python, so it is pretty interesting and pretty useful to learn the Python programming language. So that's all for this lecture, and I hope you're going to like the programming.